present OutClip, a novel evaluation metric for text-guided image editing. Text-guided image editing is a rapidly evolving task powered by vision language and generative models. These models can modify images based on natural language prompts, for example, turning a bird into a bird spreading wings. Despite progress in editing models, a major issue remains. How do we evaluate whether an edit is good? A good edited image should modify the image according to the target text while still preserving key elements of the source image. Existing evaluation metrics fall into three categories, which are preservation-centric metrics such as LPIPs or ClipEye, which compare the source and edited images while ignoring the prompt. And second is modification-centric metrics such as clip score, which measures how well the edited image matches the target text, ignoring the original image. And the last one is directional clip similarity, the only metric that tries to consider both by comparing directional vectors in clip space. However, these approaches share a common flaw, which is they are context blind. They apply the same evaluation rule to every editing scenario, regardless of whether a large change or a minor one is appropriate. This motivates the need of a context-aware evaluation method, one that can adaptively balance preservation and modification depending on the situation. Preservation and modification-centric metrics have complementary goals. The naive approach is to combine them, for example, by linear interpolation. However, this blending often worsens the performance and fails to reflect human preferences. Even the most balanced method, directional clip similarity, has two critical problems. First, it overemphasizes modification. Given two edited images, one with minimal changes and one excessively altered, directional clip similarity often gives a higher score to the excessive one, simply because it aligns better with the target text. This leads to misalignment with human perception. And second, directional clip similarity tends to focus on irrelevant regions in the image. It doesn't attend to the actual area that was supposed to be edited. For instance, when asked to add a floral shirt to a cat, it may focus on the face of the cat, missing the target. These issues demonstrate that without contextual understanding, existing metrics cannot faithfully judge edit quality. A new approach is required, one that dynamically understands what to preserve and what to change, depending on the input. To address these limitations, we propose OutClip, a metric that estimates what an ideally edited image should look like in the clip space. To derive the representation of the ideally edited image, we aim to obtain the minimal modification vector that alters the representation of the source image to strike a balance between preservation and modification. OutClip consists of two main steps. First, we extract source and target attributes using a multimodal large language model GPT-4V. From the source image, we identify visual elements that should be preserved, and from the target text, we extract that what needs to be modified. Second, we compute a modification vector V, representing the minimal change needed to shift the source embedding toward the target concept. This is done by training a linear classifier to separate source and target attributes in the clip space and solving for the smallest vector that moves the source representation across this decision boundary. Then we compare the edited image's embedding to the ideal embedding using cosine similarity. In summary, OutClip evaluates an image based on how well it achieves minimal but effective modification while respecting the source identity, making it inherently context-aware. We validate OutClip using two types of tests. The first is human preference alignment. We conducted a user study on AMT across three datasets, which are Celeb8, Editfile, and DreamBooth. Human annotators judged which edited image best satisfied three criteria, which are realism, relevance to the target prompt, and preservation of source identity. Clip achieved the highest alignment scores on all datasets, outperforming directional clip similarity, clip I or clip T, and traditional preservation metrics. The second is the ground truth selection test. For this, we created image triplets, one well-edited image, one with excessive preservation, and one with excessive modification. We tested whether each metric assigns the highest score to the correct, well-edited image. Again, our clip significantly outperformed others. It correctly balanced both aspects and showed higher accuracy scores across datasets like Magic Brush and TEDbench. These results demonstrate that our clip is more robust, reliable, and aligned with human judgment than all existing metrics. Finally, we present some qualitative results. In cases like changing hairstyle, altering the texture of an object, or editing small facial features, our clip consistently prefers subtle, accurate edits that respect the original image, whereas directional similarity often selects results that are visually far from the source. For example, when the prompt is add chocolate toppings to a donut, our clip favors images that retain the shape, color, and context of the original donut while making the requested change. Directional clip similarity may favor a completely new donut if it resembles the prompt more literally. This standard also works for a specific domain such as human face. These examples illustrate how our clip internalized the editing intent, weighing both what should be preserved and what should be modified, something previous metrics could not handle. In conclusion, our clip sets a new standard for evaluating text-guided image editing by introducing context sensitivity into the metric design. It aligns closely with the human perception and provides a valuable tool for both benchmarking and training image editing models. Thank you.